Hello everyone. Let's start with vectors. First, definition of vector. First, we have initial, final, and we have direction, we have magnitude. Our vector, we have 1, 2 units, and the direction is with plus x direction. Okay, you can also draw here this vector again, b vector is 1 unit and minus x direction. Vector, if you see any arrow of any letter, this shows you vector. It means that this is not equals to any scalar or numbers. Also, you can actually make very easy scalar or number with direction gives you vector. This is vector A, let's say 5 unit, and also we can calculate the magnitude of this vector. So this is shows you magnitude. The magnitude is just 5. It means that this is the positive x, this is minus x, and we have 3 and negative 3. This is a vector, this is b vector. A vector is not equals to b vector. However, the magnitude of this one, a equals to b. It means that a is 3 magnitude and b is 3 magnitude. So what happened is negative. This negative shows you the direction. It means that b is negative direction and a is positive direction. That's it. But the magnitude is 3. And if you want to make 2 or 3 vector equal to each other, direction and magnitude must be equal each other. Let's say a vector this is 3 unit, and we have b vector, this is also 3 unit. A vector equals to b vector because they both x direction, positive direction, and the magnitude, they are same. But we have c vector, again 3 units, but a equals b not equals c as vector because the direction a and b same but c is different. Okay, how about the magnitude? A equals to b and equals to c. Why? Because a 3 units, b again 3 unit, and c 3 unit. And let me remind you this negative shows you direction. Okay, this is not number, it's just direction. So the magnitude of this one is 3. Seems that magnitude of these are equal, but the vectors are not equal. We have vector we can add and multiply with scalar number, so a plus b, we have a and b, this is the a plus b, this is the total addition. If they are same side, same direction, add to each other. However, they are opposite, a, let's say this is the b, we need to subtract them. A, b, this portion you need to subtract them. Okay, let's say a 5 unit, let's say b 2 unit, 5 unit 2 unit. If you subtract them, you have 3 unit with 5 unit direction. We can do addition with vector. It calls and to and. Let's say we have a vector and we have b vector. This is a initial, final, initial, final. So we need to initial, final. So a, and we can add b like this. This is a, this is b, and you need to follow the arrow, initial, final. If you follow the arrow, you're gonna see the R. Or you can add A to B. This is the B. You can add A like this. Again, we can follow the arrow, initial. This is R. And in vector, we don't do this A, B, and also we don't do this. This is not addition. It must be initial, final, and direction. Again, initial, final, and initial to final. This is R. Let's add a few vectors. A vector, B vector, C vector. You can A, B, or A, C, or B, C. It doesn't matter. So I can see A, adding C is easier for me, like A plus C. So A and C, A and C. Then I can add B, something like this, and I'm gonna follow the arrow. You see initial, final. This is my R, resultant vector, addition vector. Okay, this is another example. A, B, let's say C, and D. Okay, I can add A, B, C, or D, but it seems that C, D is easier to adding each other, and A, B much easier. So I'm gonna add first, draw the D, then adding C. Okay, we have A. I can add A on top of the C like this, A, and B I can add here, B. So this is A to C. I'm going to follow the arrow. Seems that I started with A, I can finish with B. This is my R. Okay, let's solve some question on AND to AND method. and 2 and. Okay, we need to remember that if you multiply with negative number with any vector, the vector just change the direction. Okay, if you multiply by L with minus, you're gonna change the direction. If you multiply by M with minus any number, this going to change the direction. If you multiply by negative K, you're gonna change the direction. That's it. So if you have this vector, if you multiply with negative, then you have exactly same vector but opposite direction. This is minus K. Okay, let's solve a question. We have K minus L M plus M. K is same, but we need to multiply by L with negative. If you multiply this vector with negative number, you're going to change the direction. Now we have the direction something like this. So we need to, this is not again the direction, so the new direction is here. So I want to add the K. You can carry this vector to here. Everything's going to same, and you can carry the M here. Now you have M, you have M minus L and K, and you need to start with initial, follow the arrow, initial, final. This is your R. It seems that this R equals to 1. Okay, let's solve this question. So we have A vector is here, 2B, we need to multiply by 2. If you multiply by 2, you're gonna have the 1 unit and 2 unit. This is the total B. This is 2B. And you have divided C by 2. It means that half of the C, 1, 2, and you need to the half of it. So 1 vector, the 1 unit here and the second one here. So you can cancel the second one and you just have 1 vector here. So you can now add to each other. So you can carry A to B. I'm going to carry A to B. I don't change anything. I just carry the vector like this. And I can carry C to B like this. So you can follow the arrow like this. I started point and final point and initial, final, see the arrow. This is our final result. This is the R. If you want to see, if you want to check, you can see this is A. This is our R. Okay, let's find the K, L, M, N vectors. So K, so this N and M, they are same but different direction. M, this is N. If two are same and different direction, they can cancel each other, so we can cancel each other. We don't have any more M, N. We just have K, L. I can carry the L to here like this. And initial and final, my resultant R become R. So this is equals to, seems that R and N, they are same. Seems that this resultant additional vector equals to N.